Hello, so let's analyze this circuit in which we see there is a Zener diode as shown, there is a small resistor R, there is an input voltage applied across these two terminals and called as UIN, and there is an output voltage that is recorded at these two terminals called as U out, and the diode D is as shown. So how to analyze this circuit? And we know that from our previous sessions that Zener diode will work in a reverse biased mode. It means when the applied voltage U in exceeds the Zener breakdown voltage of this diode, the diode will conduct current from its cathode to anode. So remember, let's say you have a Zener breakdown voltage of 2 volt and you apply an input voltage that is greater than 2 volt, that is U in is greater than 2 volt, then there is a current flowing through this circuit. There is a current flowing through the R, and then that same current diode will allow to flow from cathode to the anode. And once that happens, you have a constant voltage drop of 2 volt across the Zener terminal, which is nothing but your U out, that is the output voltage. So this is how your Zener will, when it conducts current in a reverse bias, maintains this 2 volt across the output terminal, provided your input voltage must be equal to or greater than, not equal to, a greater than, it should be greater than 2 volt, because there will be a small voltage drop across the resistor also. This resistor has been used here to limit the current when the diode conducts the current, otherwise it may damage the current flowing through the diode, and it may damage the diode also because of the very heavy current. Okay, so this property of a Zener is used to maintain the constant voltage across the output terminal. When it conducts the current, it holds the Zener voltage across its output terminal. So even though there is a variations in the input side, the diode is entered into breakdown mode and it will maintain that voltage across its terminal. So usually you connect a resistance in the load, and that is called as load resistance. You connect that resistance across the output terminal, and the current that will flow through the load is called as load current. So let's understand the value of that current when it flows through the circuit. So that current I can be equated as UIN minus VZ. VZ is the drop across, it's a Zener voltage when it conducts the current and it is turned on in a reverse bias, divided by the value of R. So this is the value of the current that is flowing through the circuit. Now the question is how to choose the value of R, because we will choose the diode as per our specification and it will have VZ, Zener voltage, already from the data sheet. You will already also know what is going to be your unregulated input voltage that will be regulated by the Zener diode eventually. So let's say you have a 5 volt and you have a Zener voltage of 2 volt and you have to choose the value of the resistance. So you need to refer to the data sheet and you can then see one more parameter that is called as IZ from the data sheet. Remember, IZ is the current flowing through the diode when it will get its breakdown, when it will turn on. So IZ is nothing but your your current flowing through the diode. So you get the value of IZ, you get the value of VZ from the data sheet, which is 2 volt, and IZ you can refer to the data sheet, and then you know how much is your unregulated power supply. Based on the value, based on that you can calculate the value of R. Remember, you will also connect the load here, through which, across which you need to maintain that constant voltage of 2 volt. Okay, so you also know the value of RL load. Let's say it is 1K. So accordingly all these values are known. You can get the equations and apply those equations such as Kirchhoff's laws, Ohm's laws, and get the values of various resistance and the currents and the voltages. Just the thumb rule is that you have to make sure the value of the resistor should not be very small, because if it is very small, remember we have said that this value of resistor R is to limit the current flowing through the Zener. So if it is too low, then the large current can flow through the diode, and also through the load. This current will also flow through the load. So this is not an optimum way. It may damage your diode or a load that the current will flow through. On the other hand, it cannot be too large. If it is chosen too large, it means there will be a large voltage drop across this resistor VR, and then the Zener diode may come out from the reverse biased region. The voltage across the Zener, if the voltage across the Zener falls below its breakdown voltage, that is VZ, it will not conduct the current, and the current will decrease and it will come out of its turn on mode, and then your output voltage is not a regulated version of input voltage, and your output voltage will still be unregulated. There will be a variations in the output voltage whenever there are variations in the input side or in the load. So this is how the function of the Zener as a regulator we have seen in this module. So hope you like this video. If you did so, share with others, like it, and also subscribe to the channel, and stay tuned for this more informative, technical rich content. Wish you happy learning.